Good day, everyone, and thank you all for joining today's data-based modeling and design with SQL. I am William Cosina, and I am hosting these sessions. But for today's session, will be run by a very good friend, someone whom I've known for years, and he's a data architect, a PhD student in data, working on augmented reality. And since I've known him, he's been talking all things about data, blockchain. There's no one better to leave you in their capable hands than in the hands of PhD candidate Carlos Ankora. Carlos, thank you, and please go ahead. This will be my first and last introduction of Carlos. For all subsequent series, Carlos will be hosting it and leading the entire session. You are all welcome to today's session, and let's have a wonderful time with database modeling and design with SQL. Thank you, Carlos.
Thank you very much, William, and I'm very grateful for putting me on this. Yeah, I've been following your design thinking series, and these are very big shoes that I'm coming to fill in for the Friday session, but yeah, we'll go. So we'll be doing database modeling and design with SQL, yeah. So the introduction has been done already, so there's nothing to say about me. My name is Carlos, yeah. We'll start with data and information. These two terms are normally used interchangeably. You find people refer to information and data in the same way. Yeah, it doesn't really change anything. But normally in technical terms, data is anything where normally people would say, okay, it's the raw facts. Raw facts. I would say that data is anything that we can capture as facts. When we capture the data, it's in some raw format. We need to store it and you retrieve it for later use. You can also refer to it in some later conversation or something like that. So for example, if I come now and I say, everybody here should, in the chat, should just put in maybe their age or, okay, no, not age, maybe their income or expense in a month. When I collect all of that, that is data. But when I take that data and I process it, by processing, I mean, maybe I find the average income earner, or maybe the person with the highest earner, or let's say I perform some variations or some standard deviation kind of thing on it. Then I'm trying to derive some meaning out of the data that has been collected. Then it becomes information. But information can be represented in various ways. It could be in a tabular form. It could be in the form of a graph. It could be in a chart form. Yeah. So anytime data undergoes some form of processing, it becomes information. But as I said, we always use the term interchangeably. About database. What is database? Database, we say, basically is a collection of data. It's a collection of data. But then, it doesn't mean that when you collect any form of data and put it together, it becomes a database. Why? Because the data has to be organized and related. Organized in the form of, the data should have some kind of characteristics. The data that we are collecting, and it should be related to each other, not just any random data. Else I'll come and say, okay, let me take somebody's name, another person's address, a third person's mobile phone number, another person's email address, and put it together. Will I call that a database? No, because that data is not organized, it's not related. But whatever data that you collect, well, even as it is organized and related, it has to be logical. So we say that a database is a collection of data, but the data has to be organized and related logically. So an organized collection of logically related data, we say that is a database. We'll see what makes the data organized, what makes it related, and what makes it logical in the subsequent sessions. Yeah. Then we have what we call the database system. There are two things. There's a database system, there's a database management system, which we normally refer to as the DBMS. A lot of these two also are used interchangeably. People could refer to the DBMS as a database system and all of that. But the database system is actually, it comprises of the data that you are going to store in the database. It also includes the software that you are using to manage that data. That is what we are calling the DBMS. It also includes the application software, maybe a web form or a Java application which interacts with the data. It could also include the user of the database. All of these form what you call the database system. So the database system is not just about the data or the database or the software. It includes the user, the application software, even sometimes the architecture behind the setup of the database also forms part of what we call the database system. But in the database system, we have what we call the DBMS, that's the database management system. That is simply the software that is used to create and maintain the database. And it forms part of the database system. So the DBMS is simply the software that is used to create the database and maintain it. In maintaining it, we could add more data to it. We could update the data. We could delete the data. Anything that we do to the data becomes some form of maintenance. And the DBMS is what helps us to do that. These are examples of the DBMS that are commonly used. We have the Microsoft SQL Server. We have Oracle. We have MySQL. We have SQLite, PostgreSQL, and Microsoft Access. All of these have their strengths and where they don't, their weaknesses elsewhere. So depending on the platform that you are going to deploy your database, that could inform the kind of DBMS or the kind of software that you would use to manage your database. Someone may ask, where will Excel come in all of this? Because a lot of people would say, okay, Excel is also used to manage data. Why am I not putting it as one of the DBMS? Okay, so Excel technically is referred to as a spreadsheet program. Spreadsheets and databases have some things in common, but they are not the same thing. Both spreadsheet and database systems are used to store and manage sets of data. So both of them structure data sets in rows and columns. That's the vertical and the horizontal in cells. Okay. They both offer a range of processing functions. They can manipulate data. They could be used to sort and filter data. They could perform calculations on data. Both of them can do that. So if all that you need to do is just about these three things, it's your choice. You could use the spreadsheet or the database. Both of them have their own strengths to create a good balance. So spreadsheet is user-friendly. It's not very difficult for someone to start learning the spreadsheet application. It's quite flexible. You can perform a lot of functions or functionalities on it. And it gives you some good formatting and representation of data in graphs and charts and all of that, coloring and that kind of thing. Yeah. But the database has its strengths also. We could talk about data integrity. It ensures that the right or accurate data goes into the database or is stored on the server or something. Yeah. And it's one of the strengths of the database is security and storage also. Databases are centrally stored. So all the storage is at one place, and there's a proper security system that enables which user has access to what kind of data. Then we can talk about scalability. When you're storing information in databases, the data keeps increasing. So once you have a lot of space on your hard drive or your storage device, the database should be able to accommodate it. So still comparing the spreadsheet and databases. The spreadsheet is very simple to understand, but the database requires some technical knowledge. Yeah. So a lot of the times with database, you need to go through some form of training before you can effectively use the database. Spreadsheet has the same interface for data entry and editing. So yeah, it's always that spreadsheet form where you enter your data and all of that. But the database has different interfaces for data entry and editing. So you could have a web application designed with HTML or PHP. You could have a Java application. You could have a Visual Basic application interacting with the data. User access control is difficult in spreadsheets, whereas in the database, because there's a centralized data storage, there's user access security, and you can give permissions on who has access to what kind of data. Some people can just view the data. The same data, some people can only view certain portions of it. Some people can update or edit some information. Some people can just add, and maybe the administrator could have the rights to be able to delete data. Yeah. Then there's duplication of data in multiple sheets when you are working in the spreadsheet or Excel system. So you realize that, or even in workbooks, you realize data is duplicated in several of these sheets. But in database, it avoids the duplication and redundancy using what you call the keys. We'll talk about primary keys later. Then the last one, the spreadsheet enforces less rules to ensure data integrity. But with the database, there are more rules to enforce to ensure that the data that is going there is accurate. So it uses keys and what we call the referential integrity constraints to ensure that the right kind of data is being stored. Remember, garbage in, garbage out. If you don't put in the right data, the data that you're going to fetch is also going to be wrong. So you need to ensure that the right data goes in there. But in all this, the database has to be modeled and structured properly before you can benefit from these. Not just any database will do all this. So you need to understand how the data should be modeled before you can ensure that the right data is going in there. There's no duplication, there is no redundancy of data. So in making a choice whether to use the spreadsheet or the database, there are some questions that you need to ask yourself about the operations that you want to perform. First of all, you could ask, do several people need access to the data and at the same time? Whatever data that you are trying to store, would you have a lot of users trying to access the data simultaneously? Do you need to safeguard against erroneous entries? Garbage in, garbage out again. When the wrong entries go in, it could make your data not very credible. So do you need to safeguard your data from these errors? You have separate spreadsheets that contain related information. Normally, if you do, then that means there's going to be some duplication or some redundancy of data. So you need to consider that. Then do you want to maintain data for ongoing use? Is it a one-time data that you are just storing, or is something that you're going to be adding to it? You're going to be adding more sets of data. Or do you want to combine data and generate specific reports, combining data from different sources or different locations and putting all of them together to generate a report? If your answer is yes to all of these questions, then I think you might need a database to store your data to be very relevant to do that. So why database for business professionals or business analysts or people who are working within the business area? Sometimes they feel like, okay, I'm a business guy, database is quite technical, I might not need I don't really need the database knowledge for anything. But sometimes it's necessary. In working in agile environments, it's good to have some level of understanding to foster collaboration. Agile says that collaborate together, work from scratch, and go up to the end. When you're in a session with these developers or the agile team, sometimes you need to have some good understanding of the systems or whatever they are working with. Else you end up, maybe sometimes you say something that might sound silly, and they'll be looking at you somewhere like, where is this guy coming from? Yeah. So it's good to have some good understanding about the systems or the data that you are working with, so that your contributions will be beneficial to the group there. So that when you talk, they'll be like, oh yeah, this guy, he knows his stuff. Okay. It allows you to better understand and interpret documents and that contain results from databases also. So a lot of the time you would pull information from databases, and when you pull it out, based on your understanding of how the data works, it gives you a good understanding or a better understanding of the information that you are collecting. And it enables you to conduct a deeper analysis of data that is stored in relational databases. We'll talk about relational databases later anyway, but it's all about being able to relate data among different entities or different objects. So when you're analyzing the data, you need to compare the different entities and see what kind of inference you can draw out of the data. It gives you an improved understanding of data flow in information systems. So it makes it easier to create reports and apply them to your needs, because you have an understanding of what kind of data or how the data has been modeled. When you're trying to create reports out of it, it makes it easier, and you know how to format your reports to meet your business or organizational needs. Then the last point here, I talk about the ER model. That's the entity relationship model, one of the most common models that is used in structuring your database. So the ER model is a good way to get the dialogue between the business analyst and the developer flowing. So with the ER model, the development team or the database team seems to appreciate the effort in building or designing the database. The ER model is one of the models that I personally like, because it gives you a visual representation of the model that you are creating. And it uses three things. We call it the entities, the attributes, and the relationships. We'll talk about that later, but yeah. So with that, you're able to visualize how the different sets of data correlate or connect to each other, and what kind of results you get if you are going to store data in them and generate reports out of this. So I believe with this, you would agree with me that even as non-technical people, it would be good to have some understanding of how databases work and all of that. So in the subsequent sessions, we'll be going from taking some real scenarios or how to even start from scratch. You have some data that you need to model, how to perform your requirements and design the data and modeling the data to building the database. We'll be taking it in different stages like that. I think my time is almost up now. So we'll take some questions, we'll have some discussion, because I know some of you are quite familiar with the data and the modeling and all of that. So if you have some discussions or some comments or some questions and answers, they could come, they are welcome. Yeah.
Sorry, Dapo here. Just make it, good start. I'm enjoying it so far. So, keep it up.
Yeah, thank you. Any questions?
Yes, thank you very much for the very beautiful introductory to this very important session. Would you mind giving us a preamble as to what to expect next? I really have enjoyed this intro, and you've literally whet my appetite, because data modeling is very, high on my need to know or must know list of things I need to know to help me keep my job. So what are some of the sessions that you've got coming up, please?
So what I intend to
as well.
Okay, so what I intend to do is we are going to take it from scratch. you have a case or a scenario, you want to build some, or you want to model and design a database out of it. What are the steps that we will take? What do we need to do from the beginning? Maybe gathering the requirements, whether we are going to use user stories or interviews and all of that. We should be able to identify the three main elements that we need to model the data. We call them the entities, the attributes, and the relationships. So look at how to identify these entities, how to identify the attributes out of the entities, and then how to create relations among them. So if I take, let's say, a company database, I want to build a database for a company. Some of the entities that I would identify would be maybe the employee. I could talk about the department. I could talk about maybe the payroll or salary or the job roles and all of that. Then I need to identify what information do I need from the employee, from the department, and from all the other entities that I have identified. Then how do I relate the data amongst all these entities that I've identified? So all of these forms part of the data modeling sessions. Now, there's something that I would maybe, if I don't know how to structure that, but maybe there are some of the sessions that we might just go into some breakout groups, and when we are, I think we have some good understanding of how to identify the entities and the attributes and the relationships, we'll take some real life scenarios, put ourselves into breakout groups, and then we would try to identify, try to have a model of doing the model of a real life situation and that kind of thing. I'll see how that will play out in later sessions. Yeah.
Okay, thank you. Is there any textbook or any kind of reference, anything you'd want us to read to be prepared for the next session, please?
Okay, I have some course book. Okay, I would get one that is quite simple and send to you. I'll put it in the group and we all can have access. Yeah.
Okay, thanks.
The Don Carlos, hi.
Hi, UM.
Hi.
Hello.
Oh, sorry, that wasn't UM.
No, it wasn't UM, but I know my name is on your mind, so that's good. Yeah.
Then maybe let me take the other person.
I'll wait for you to take Zafar, then I'll come along.
Oh, is Zafar?
This is someone else. Hello.
Hello.
Yeah, hello.
Right.
Can I go ahead?
Yeah, I think
go ahead.
Go ahead. Question.
Okay, yeah, just a random one about Google Sheets. What's your view on Google Sheets? You know, they are spreadsheets also, but they can control access and things like that. Okay,
so I mentioned spreadsheets. Okay, so the two main spreadsheets that I used are maybe Excel and Google Sheets. Normally, the Excel was one that you'd have one user using it at a time. Then came Google Sheets that allows multiple users to access the data and be able to perform operations on the data. I think that was a very good leap because one of the main disadvantages of Excel was when only one user could use it. But Office 365 and Google Sheets have come to allow multiple users to access it. But then again, it comes where sometimes you need to segment the data to the different users that are using it. So maybe there's some section of the data you need a user to just to be able to view it. Then that same user should be able to update another section. In that case, the Google Sheets or the spreadsheets have a bit of deficiency. So that is where the database takes an advantage because of how it controls the user access to the data. Yeah.
Thank you.
Yeah.
Can I add something into it as well, Carlos?
Yeah, go ahead.
Yeah, with the Google Sheet also, what gentleman mentioned just now, very nice, good presentation as well. But Google Sheet does is that when, for example, if I'm working on my computer something, at the same time it's collaborated. So whoever else is using, they can straight away see it. It straight away saves it. So that's the difference between Excel and Google Sheet as well, which is a big advantage, to be honest. But you would never compare a spreadsheet or Google Sheet with any database. I would think so.
Okay.
Can I ask a question to this? Because I know when you are using Excel, and you create a master.
Oops.
When somebody, when another person is working on it, the person needs to create a copy of that master. But does it mean Google Sheet doesn't, overrides that copy of the master? Or
I didn't get you. So when you are working, you mean when you are
when you are
working
working on Excel?
Okay.
When you are working on Excel and you create a master, when somebody else is working on it, it will say, and you want to save, it will say you are saving a copy of the master. Now, what I want to ask is, when you are using Google Sheet tool, does it mean it overrides that copy of the master and just goes to master straight? You save straight onto the master.
Yeah. So Google Sheets, because there's just one file that you are all connected to online, you are all working on the same data. So whatever changes that you make, it all goes into just that one document that you are all working in. Yeah.
Thank you very much. And great presentation. Thank you.
Thank you very much, Samuel.
Can I ask a question in regards to your presentation, please, if you don't mind?
Yeah, go ahead.
Yeah, can you explain a little bit more about data modeling? I know everybody speaks about data modeling. I'm creating a data model. In my current project as well, I have to deal a lot with the data modelers. What exactly mean by, in a simple English, I'm sure for other people's, benefit as well, if you can explain what exactly is data model. So, for example, my name, my address, my phone number, would I call that as a data model if that's the only information is required for the database?
Okay, so let's take it this way. A model generally is a representation of the actual something. So when I want to put up a building, I need to have a model. The model is more like the plan, whether it is just a normal plan or a 3D plan. I need to have that kind of plan so that when I'm building, that plan serves as a guideline or a framework that I'm using to build my house. When you're coming to build a database, you need to have that kind of model. So the model serves as your guideline or a representation of how you want your data to look like. So that when you do that, now when you start building the database, you know that this is what I'm doing. I'm always going to refer to it. But before you do the modeling, you would have to break down whatever scenario that you are modeling into very basic terms. Then you now look at how to put them together. So trying to relate the data is one of the critical aspects of data modeling, because if you don't model your data well, that means your data is not going to relate very well, and that will lead to inaccuracies or the database not being quality. And when your database is not quality, the reports that you're going to generate out of your system is not going to be of good quality also.
No, thank you very much. Very good explanation. And another question, follow-up question to this as well for data modeling. Do you use any specific tools, or it depends which, for example, if you're using SQL or you're using any other databases, they have their own tools and you will build your model with them?
Okay, so there are a lot of digital tools that could be used to model your data. Some people would like to just draw on paper and just do the design on paper. Other people would want to use maybe Microsoft Visio or some UML tools or Visual Paradigm. All of these allow you to create these kind of models in a way.
Right. Thank you very much.
So it doesn't really depend on what kind of SQL you are using. The model is not dependent on the DBMS. It's quite
that's
different.
very good. No, very good. Thank you very much. Thanks a lot.
Yeah.
All right, so I'll come back to you now, Carlos, yeah?
Yeah, we will.
Oh, my apologies. I've taken over most of the time.
It's fine.
No worries. Very great work. Thanks very much, Carlos, for that. Really enjoyed that. So one thing is this PowerPoint. Can we have a copy of that later on, please?
That's number one. Yeah. I'll make this available in the group. Yeah.
Okay, that's number one. Number two, Lady B asked a question about a kind of reading material. Yeah, I mean Barbara, we call her Lady B, but her name is Barbara. So about material that we can have access to in preparation for the next sessions. Yeah. Now, I was of the opinion that instead of having like a big book or a big textbook or whatever, you are a PhD guy, so you read a lot of big books. But if there is like something that you can give us, just like maybe something specific, like the next session is going to be on this, just read something on this that will not take too much of time, like maybe 30 minutes, 40 minutes kind of stuff, or a YouTube we can watch for maybe some 10, 20 minutes, something like, just to prepare us for the next session. So we take it step by step. I think that would be most appreciated from my own angle.
I think that's fine. So what maybe I can do is, before the session on Friday, maybe on Wednesday or Thursday, I'll get the material that I would use. I'll send it so that you guys will go through even before we have the session.
Yeah.
Maybe I can be doing that. So when I come, at least some people have gone through, then we'll have some discussion on it.
Fantastic.
Yeah.
That's called flipped classroom. Yeah.
I think someone put a question on the chat, and I'm not sure if that was answered yet. What are the definition in layman's terms, examples, entity,
the entities and the attributes? Okay, yes, I don't want to put all the information in the intro, so I'll take that in the next sessions. I'll talk about entities and attributes and their relationships in the next session. Today I just mentioned it, but not to give detailed explanations into them. So we'll look at that later. Yeah.
Okay. All right. Thank you.
Okay. Okay. I think our time is up, and we would end our session here. We don't want to be going past our 30 minutes. So, yeah.
Just one quick one in relation to these courses or material, Carlos. I believe compared to books, it's better to go through video or some project when that's where you learn more. But if you have any specific course you can recommend, because you are experienced one, if you tell me, I may be able to, because I'm signed up with a number of training online sites which I pay, I may be able to download it for everybody and it can benefit everyone. So I don't mind doing that.
Okay. So we'll stay in touch and to look at all of
this. Please. Keep in touch.
Okay, sure.
Right. Thank you very much.
Okay, thank you very much. William?
Thank you, Carlos. And it's been a wonderful presentation. I'll be sitting in every Friday, so I hope everyone joins us every Friday. And we would like to take a quick picture so that Carlos doesn't feel lonely. So if you could all join us in taking a quick picture, we will be using it for our LinkedIn page just to celebrate the wonderful work Carlos is doing. Yeah. So I am all ready. Let's put out a big smile. And yeah, thank you. And have a wonderful day. It's been a real pleasure having you on today's session.
Have a lovely weekend, everyone. Bye.
Have a lovely weekend.
Don't forget to get the